Perfect, cool. So we're basically doing another exercise, another take on the exercise of what is the Laplacian. No, what is so the exercise was this exercise with the graphs, right? So let's start the session. Let's resume the session, and yeah, sorry, I'm not pausing anything. Okay, so we're getting started. So we have our notebook here. And is it taking slowly because of these? I guess it's thinking. Yeah. So we are now recapping. We're here. So we're recapping what the Laplacian matrix is. And it's my mistake that we're starting from scratch because I actually had done this before, but we regenerated the plan. So I'm just not, I'm thinking about this anyway. Anyway, let's get started. So we know what the Laplacian matrix is because we did this last time, but let's repeat this. So the Laplacian matrix is if we have a graph that is like that, like this, there's a node in here, and then there's another node in here, and this is 1, this is 2, and this is 3. The Laplacian matrix is essentially, it encodes two things. It encodes how many degrees each node has, 1, 2, and 1. And sorry that it's being sluggish, and I think that's being sluggish because of open code. And then the off-diagonal elements encode, basically encode the stuff that is like for each row and column, it encodes, it's actually modifying the app or something. Anyway, it's telling us whether they're connected or not. So 1 and 2 is connected, it's -1. 1 and 3 are not connected, so it's a 0. This is a -1. This is a -1 because it's 2 and 1, and this is a 0, and this is a -1. This is what it is. And yeah, completed. Nice. I mean, that's good. So it's a bit sluggish because of these guys. I'm sorry. It's asking me a question now. So let's pause this for a second. Let's just pause this for a second. We're pausing the monitoring, and we're going back here. So how should a mobile view sync with desktop session? It should be an independent session. Independent session. Model dialog, drop down, full model array with QR code. Please. Swipe implementation, custom touch handling recommended. Yeah, let's go with this plan. Okay, let's continue. So it's a bit sluggish, but cool. Now compute the Laplacian matrix L for a simple graph such as a cycle graph with 4 vertices, and then find LS for a subset of 2 vertices. We can do this here, really. I mean, it's that's a relatively easy task to do. So we're gonna clear these. And sorry that it's sluggish. It's sluggish because of this, and because my computer is a fucking shit. So it's a cycle graph with 4 vertices. Is 1, 2, 3, 4, and then it's basically these, and these, right? That's a cycle. I think that's a cyclic graph. The Laplacian of these is very easy. So the L is very easy. The Laplacian of these is basically 2 in every single diagonal element, because they all have 2 connections, and then it's only 1, 2, and 1, 4, right? So it's going to be 1, 2, and then obviously the symmetric one, and then 1, 4, right? So here and here. And the rest are going to be zeros, right? And then we're going to get a very similar shape for the rest of things. It's going to be the second node with the 1 are connected, the second node with the third are connected, and the rest will be zeros, right? So that's it. I mean, sorry, it's kind of bad, but it's like the way it is. And then find LS for a subset of S2 vertices. So LS for a subset of 2 vertices, let's say that we pick subset S of 2 vertices. But don't I have to... But this makes no sense, right? A subset S of 2 vertices. Because it makes no sense because the problem is actually about S being a location JS where the vertices is. Oh no, it's actually vertices really. I say that a set of vertices S is what? Vertices S GS. Okay, I'm confused right now. Or is it just that we are so ESS is basically, but only the edges between vertices in S. Okay. Suggestion: consider what it means for a matrix to be positive semi-definite and think about how the condition L is positive. No, well, I'm not there yet. What I want to do is I want to yes, I just got confused for a second, but now I understand. So what this is telling me is that I want, yeah, so the subset so S, let's say it's 1 and 2. So now I'm just gonna do 1 and 2, and what LS is gonna look like is 1 1 and then 0 0 0 everywhere, and then only and everything else is gonna be 0. So only this kind of, you know, thing here is gonna be connected. I think that's what it is, right? Compute the Laplacian matrix L for simple graphs is a single graph with. I mean, it's interesting to see that essentially what is happening is that if it's a cyclic graph, what you're getting is like a reduced, everything is zeros, and then you're just getting like a sub matrix in there. You know what I mean? And I think I'm done with these. I think I could just archive this one. And yeah, cool. I mean, it's fine. This suggestion. Okay, so let's think about this. So consider what it means for a matrix to be positive semi-definite, and think about how. I mean, this is something that I definitely don't know, right? So what it means that for something to be positive semi-definite. No, it came back. So it's not okay. So maybe I have to. Maybe I have to figure out a way to tell that this came back. I think I just can. Okay, so compute the Laplacian matrix. I mean, I have done these. That's a good use case. How should I actually how should I get these picked and checked? That's a good question, right? And look, they fucked up my plan again. We're almost there, guys. We're almost there. I think we have a good flow. I'm gonna stop here now. I'm gonna pause these. We have a good flow. And I'm gonna wrap it up here. It's been 42 minutes now. I'm gonna wrap it up here. It's been a good flow. I'm gonna spend the whole night fixing these, and yes, and I think so. That's a problem. That's one thing here. It's all good, brother. You should be monitoring me if I post you, bro. So that's something to fix, and then this is also to fix, and the mobile view is now perfect, and I think we have it, guys. I think we have it. That's very good. Very good. This is good. I like this. I like that I can just pop it out like that, and put it out off screen, and yes, that makes sense, because I can now share screen, and then yeah, that's it's so perfect. I can't wait. I can't wait to launch this, guys. I really can't wait to launch this. This is actually very, very, very cool. Awesome, guys. Yeah, see you tomorrow. I'm going to try to not broadcast, but I'm going to try to publish as much as I can overnight, in terms of progress and everything. The plan is definitely fucked up. Should just be the same. Anyway, peace and see you tomorrow. Very good stuff. Just very good stuff. Very good stuff.